Very good morning, all of you. I hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session, right? In yesterday's session, we discussed about why you should learn SQL. So, nearly every domain of IT needs SQL, isn't it? Then, different applications and how they are powered by data, and to talk with that data, you need SQL, isn't it? Then few applications I listed, around 8 applications I listed where SQL is needed. And then I asked you people also. So you people also gave me some examples, very good examples. Then some basic terminologies we saw, like what is data, what is database, and what is database management system. So I hope all the things are clear to you, so that we can start with today's topics. Now, yesterday we discussed about what is database management system. So I told you it's a software which is taking care about your database, is creation of your database, maintenance, then manipulation in your database, retrieval, security, all that. But how we talk with this database management system? By one language called SQL. Correct? So few famous available here. Some are licensed version like SQL Server or Oracle. They don't come free. And some of them are open source, freeware they are available. Like MySQL is there, Postgres, even this MongoDB and all. MariaDB is just a variation of MySQL. Okay. And some of them, like SQLite and all, they're used for cell phone applications and all. Some of them are cloud based, some are NoSQL based, some are relational, that is SQL based. So few I have listed here. Okay, you can just go through it. Now this Snowflake and all, this is also becoming very famous. Even this data bricks and all for analytics and all people are using. Okay. Few I have not listed like Firebase and all. Firebase is also cloud-based NoSQL database. Okay, so few I've listed, you can just go through it. SQLite and all is a very common database management system related to phone applications and all, you can make use of it. Okay. Now we are going to discuss about what are different types of database management systems. Mainly, there can be many more categorization, but mainly we are categorized into two things. One is relational database management, relational database management system, and another is a non-relational. Okay. So main points we will try to differentiate between them, like what characterizes a relational database and a non-relational database management. Okay. The speciality of relational database management system is everything is stored in the form of tables. Getting here, everything is structured in the form of tables, and tables are made up of columns and rows. Columns are describing about the entity like roll number, name, marks, or employee number, employee name, salary, department, whatever. And the rows contain information about that columns. Okay. So here everything is kept in the form of a row represent one entity, you can say. Okay. Or it is called as a tuple or it's called as a record. Okay. And the columns are describing that record. Means for by what the record is made up of. Whether it's made up of number, name, salary, department, whatever. Okay. So columns and row structure. That is the speciality of relational database. And then multiple tables you can have, and the tables are not having any physical connection, but they are connected based on some column. They may have some column, like one column is referring the value from some another column. It's generally called as foreign key, primary key. We'll be learning about that, don't worry. So based on some common column, they are connected with each other. So in relational database, the specialty is everything is kept in the form of tables. Tables are organized as columns. Column are describing the records, and one row represent one record. Okay. Generally in mathematics theory, if you have some basic background of discrete mathematics and all, based on that only, this is a concept derived from there only. One record is having related values. Therefore, the terminology is coming from there, relation theory. Okay? And here the structure of each table is fixed. We call it as schema. Schema means design. So once the design is fixed, you can modify that design, but frequent changes are not there. Correct? Once the design is done, you just make use of that table. Okay, for adding the records, deleting record, modifying record, retrieving the record. Generally, the schema, that is the design, frequent changes are not there. The design is fixed. It is well structured. Correct? The structure of the tables are fixed. Okay. And to deal with these tables, we need to use one standard language, that is SQL. Means without SQL, we cannot communicate or we cannot do operations on these tables. So SQL is needed. And generally, whenever there are large number of transactions going to happen, large number of manipulations going to happen, and complex queries are there. Like you are retrieving the values from one table, second table, and then you're combining that. So that time, relational database is always preferred. Getting? So example, wherever there are complex queries, like based on joins and all, okay, or frequent transactions are going to happen on your database, then relational database is well suited. Getting? The structure is fixed. It doesn't manipulate, it doesn't change. Changes happen vertically just by adding new records. So when you're just keeping adding the record, so vertically it keeps growing, not horizontally. Because once the design is fixed, the columns are fixed. Generally, we don't make changes. We just keep adding the records. So vertical changes happen, not horizontal. Get it? So schema is fixed. The table structures are fixed. The tables are related to each other based on some column. If you want to do any work with these tables, SQL is needed. And as I said, always use when there are complex queries or frequent transactions are going to happen on your tables. Then go for relational database. Best example is MySQL. You can take Postgres, Oracle, SQL Server. They all are relational databases. Get it? Now, I remember I started my journey with in 98, in 1998, I cleared my engineering. Before that, 4 years back, then I remember we started with on Unix, we used to use that Sybase. Sybase is a database, and in C++, we used to do the connection. Then Delphi, we have used Ingress, Postgres, then uh, many were there. Magic, so many, and many have gone in history also. Okay? Uh, so many relational database management systems are there. Now coming to non-relational database, this is a modern concept. Relational database is too old. In 19 from 1970s, that is IBM project. From there it is coming. Coming to non-relational database. In non-relational database, there is nothing well structured like this. Here, everything is kept as a document collection. You call it as document collection. Okay. And in that document collection, everything is a doc. Correct? Each one is kept as a document, we can say, doc one, doc two, doc three, going on. And each document is just a key comma value pair, key value, key value. And the key is unique. Values can be repeated. So one document can contain any number of key values. Next document again, key value. Get it? But in each document, not necessarily the same key values can be there. In one doc collection, if you have created one doc collection called employee. So in one document, you're keeping employee name and the salary. Maybe in the next one is name, salary, and department. Maybe in the next one, name, salary, dependents, department. So the structure is not fixed. They don't have any pre-decided structure. It is just an empty collection, empty document collection. Go on adding the docs in it, and every doc can contain any number of key and value pair. Getting so it's an unstructured way. Here it gets extended vertically also and horizontally also. Why horizontally? Because the number of keys and value are not fixed. Somewhere there can be two, in the next doc there can be four also. Get it? So there is no pre-decided schema. The design is not there. It is simply a collection of document and you can keep adding the documents in it. Every doc contains a key and value pair. Okay. And normally, and to interact with this, there is no SQL. Therefore, they are saying not only SQL. They every non-relational database they give their own libraries. Like MongoDB will give its own library, or if you go to Firebase, they will have their own library of adding the doc, deleting that doc, retrieving all the docs. Get it? So they don't have any standard language like SQL. Get it? And usually when there are complex queries, we should not prefer this. Get it? Means they don't, they have very limitations. Means like foreign keys and all, connecting one doc set with another is very less or it's near to not. Get it? Generally use it when you just want to store the information and present it. Just you want to dump the information and just you have to present it to the end user. Then we generally go for non-relational. Get it? So MongoDB, Firebase, get it? They all come under many cloud-based database management systems are there nowadays. They all go under non-relational. Get it? So usually when there are large transactions or complex queries, it is not preferred. Get it? It is generally preferred when large data is to be just dumped and just the data is to be presented. Examples here I can give in case of relational banking systems are there. Banking systems well suited relational database, banking system, e-commerce application, shopping websites and all whatever are there. They usually prefer relational. Get it? So best are ERP systems. Okay, companies have their ERP systems. So they generally prefer relation because in ERP systems, large transactions, complex queries, the table structure of each entity, like employees there, project is there, their leave is there, all that things are fixed. Non-relational best example, you can say content management, like blogging websites are there, blogging and all, or social media websites are there, Instagram, Twitter, and all those. They for them the well suited is non-relational. Get it? So example I gave you like MongoDB is there, Redis and all, MongoDB, Firebase, they all come under non-relational. And Postgres, MySQL, SQL Server, they go in relational. Okay? So main points I have told you, we can go through the slide, but before that, just a quick confirmation from your side. If you have any doubts, you can ask me, or we will go through the points. Let's see. We will go through the points, and after that, still, if you have some queries, you can ask me. As I said, relational database. From this picture only, you can realize that this is the storage, your permanent storage. And on that permanent storage, everything is kept in the form of tables. And that tables are related to each other based on some common column. Okay. The structure of the table is fixed. Once when you create the table, that time only the schema is designed. You can alter it, but the frequent is not happening. It is not dynamically changing its design. Dynamically, only the records grow. Records only we keep adding. Get it? And non-relational database, see, as I said, everything here is kept as a document collection. And every document is key, comma, value. Generally, they follow one concept called JSON. I hope you have heard about it. JavaScript object note. It depends on how much programming background you have. Otherwise, leave it. JSON concept is there, which is key value pair. So what it uses, as I said, uses table to store data, whereas here they uses documents. So here everything is a doc collection. In every doc collection, there are any number of documents. Every document is just a key, comma, value pair. Get it? And here the design or the schema of the table is pre-decided, structured data with predefined schema. Here, every doc need not have same key value. Like in one document collection only, it may happen one doc is having only three keys, the next may have five keys also. Getting logs and all are also maintained if you know about it. Getting generally where multi-user environments are there, they maintain log like when the user has done the login, when he has logged out, from which machine. All that things are kept in that the IP address, the user ID, the timing, and all. Now, in that, every log entry doesn't have the same information. Each log entry may have less or more values. So generally for that case also this non-relational is suitable. Okay? Some use some other things also like XML and all. So uses SQL. You have to deal with this relational database. There is only one standard language by which we can talk, that is SQL. Here they call it as not only SQL. Correct? Means yeah, they have their own libraries. Okay? Best for complex queries and frequent transactions. Like banking system, as I said, there abundant of transactions are happening. And many times you have to join the tables. More than one table you have to join and retrieve the records, combine that and then do the presentation. Okay. Best for large volumes of unstructured or semi-structured data. Getting just where the information is getting dumped and it is just getting presented. Getting examples I told you MySQL is there, which we will be using in our whole course. We'll be using MySQL. Generally prefer learning now. uh, After this, everything will be based on open source concepts. So MySQL, Postgres, Oracle is there. SQL Server is a Microsoft product. MariaDB is just a variation. It's a variant of MySQL. Here we can say MongoDB, Firebase, Cassandra. Cassandra, like big data ecosystem, if you know, they have like DynamoDB, Redis, they all come under non-relation. Some of them are cloud-based also, like Firebase is a cloud-based database. Okay. Examples I told you, like banking system, ERP, CRM is there, customer relation system. Then inventory system. Now in inventory, the tables are fixed. The product table, the stock table, then the invoice table, the bill table, the supplier table, the customer table. All these things are fixed. Getting? Therefore, it's a good thing for inventory system to go for relational and ideal for real-time application. Yesterday, someone had given this example also of I asked them where SQL can be used. So that time I told you actually it goes under the other category. Real-time applications means I hope you know it, which senses the data from different sensors, and then the sensors are bringing the data and then they are giving it to that application, and then the application will work on it. Get it? Content management is there. Generally, these you can call as a blogging systems and all. IoT, these are generally hardware interfaced, right? Or no? Then, like your phone is connected with your smart refrigerator or smart washing machine. Okay, social media website, logs and all. Here, non-relational is well suited. Get it? Because if you go for this content management and all, so if I'm posting a blog, so in my blog, how much content is there? Not necessary. The another blog will also have a same structure. In my blog, maybe I have inserted a video also, an image also. Someone else has posted a blog. In that, maybe only the text is there. Getting? So the structure not necessary, fix it. Okay? So that was the basic between the relational database and non-relational. You can just give me quick confirmation. Okay? Because confirmation is very, very important to proceed. If you have queries, that also you can ask me. Or if it is good to go, then I can proceed with next thing. Okay? Chalo, quickly. Response is needed. You have to unmute. Just don't type in the chat window. That is one kind request because generally chat window at the end I see. So it is better you unmute and talk with me.
Yeah, we understand that.
Okay? ठीक है?
Yeah, yes,
Uh, Okay. Then
yes.
let's take it. Then from your side, you're saying it's good to go, so we can proceed further. You can explore, but again, I have given you the basic information, but every time I tell you in the yesterday's session also I told you, right? What is the requirement from the trainer's side? I told you three things, three important things. If you have attended yesterday's session, one important thing, attend the whole session without interruption. Getting 1 hour session is there. So please join and attend that session completely. Don't get in between disconnected or something. Don't get distracted. 1 hour devote. Getting for SQL. Second, I told you do maximum practice. Getting otherwise, some student what they do, they just keep seeing what I do. I do the queries, I solve the exercises, and they just watch. They don't do anything. So try to get maximum hands-on. Please try to solve each and everything along with me. If you're not able to do it along with me, at least afterwards you do it. And third, I told you, be curious. Curious means keep asking questions. It's not necessary to ask me, ask to yourself and explore. We have so many AI tools and all. You can ask to AI tool related to that some more information. Get it? So I gave you the basic information of relational and non-relational. You can explore more on it. Okay? Now moving ahead, why SQL? So already I told you, database management system is responsible for taking care of your database, which is stored on the secondary. Nowadays, this secondary is gone to cloud. Get it? Now we are moving towards the cloud-based system. Therefore, we don't store anything on the local machine. But if we consider the standard database management, so all your database, that is tables, are kept on the secondary. So looking after this, meaning creation of the tables, adding records in it, deleting records, updating record, retrieving the records, providing security to it, backup, all that facility DBMS give. But DBMS say, I cannot do it on my own. You have to instruct me. Getting? It's like, I hope you know in that stories like that jinn is there. Jinn and he rubs it and then one thing comes out of it and it says that bol mere आका क्या हुक्म है. So it's like that. DBMS says मुझे हुक्म दो, I'll do that. You instruct me. Get it? So we people have to instruct to the DBMS. We have to instruct. And then only the DBMS will obey that instruction and do the according work on this. Correct? So how we are going to communicate with the DBMS? We need some medium of communication, isn't it? Like I'm talking with you people. So why? Because we people are having one common medium of communication, that is language. And which natural language? We are using English. So every language is having its character set. Yes or no? If you have studied Hindi, English, Marathi, Sanskrit, okay. So all these languages, do they have their character set? They have their vocabulary. They have their grammar. And then using that vocabulary, that grammar, we build sentences. And are that sentences acting as a communication from one entity to another? Yes. Get it? Same way, user is supposed to instruct to the DBMS. And therefore, they need to have some medium of communication. and that medium of communication is SQL. Correct? So it is also a language. It is also providing its character set. Okay, it will have its vocab. It will have its grammar. Grammar means, I hope you know it, the rules, which in our computer terminology, instead of calling grammar, we call syntax, syntaxes or semantics. Correct? So grammar rules are there, vocabulary is there, character set is there. All this we will use and build statements called as instructions. And that instructions are given to the DBMS. DBMS takes the instruction, checks whether the instruction is correctly written or no. No, then it will give an error. Yes, then it will compile the instruction, execute it, do appropriate changes here, produce the result, and give the result back to whom? To the user. So in short, this SQL is just a medium of communication between us and the DBMS. How we are going to instruct to the DBMS using SQL commands. Get it? So it's a language, but just remember it is a non-procedural language. It doesn't come under procedural. I'll give you the difference between what is procedural and non-procedural. But basic idea you got it. Why we need SQL to instruct DBMS. That's all. How we are going to instruct DBMS that please take this value and insert it in my table, or give me all these records, or give me all the records from my employee table who are staying in Pune city, or give me all the employee records who are having salary more than 50,000. So how I'm going to instruct to the DBMS? DBMS saying, I'll give you what you want, or I'll do what you say, but please instruct me. And we are going to instruct to the DBMS with the help of SQL. Please remember, there is no other option to talk with DBMS other than SQL. Getting it's more than 55 years. SQL is still there and will remain. Getting what I'm trying to tell? Around IBM's project started in 1970s, where they started with their own database management system, DB2. And for that DB2, they started with a project called Standard Language. And they started with one language, SQL, then they moved to SQL. I'm coming to the history part and all. So there is no other means by which you can talk with DBMS. Means if you are a full stack developer also, you are a backend developer, like you are working in Java, Spring Boot and all. So using that Spring Boot also in at the background level, means at the low level, you have to interact with SQL. Though you are not going to use SQL directly. Like suppose you are a Java programmer and you are writing some Spring Boot services, that Spring Boot will take help of Hibernate. Hibernate will background create queries and then give it to your database. Means without queries, we cannot talk with DBMS. Okay? So that is the specialty. So we need a language to interact with DBMS. How you are going to talk with the DBMS. And there is a standard language that is SQL. So we use SQL to interact with DBMS, to instruct to the DBMS to do all these CRUD operations like creation of your table, inserting records in it, retrieving records, updating records, deleting record. For doing all this activity, we will instruct to DBMS using SQL. Okay, so I hope you understood this basic thing, you got it. Then quickly about MySQL. Okay, what is MySQL? That we will talk. Then we will discuss about little bit history of SQL, and then we have to dive into installation, right? Many might be thinking when we will start with the actual practical. Only today's session is theoretical. Then our all practical journey is going to start. Don't worry. Correct? So what is MySQL? Just remember, MySQL is not SQL. SQL is a separate language used for interaction. MySQL is a name given to one database management system. Means the makers of MySQL, they gave the name to their database management system as MySQL, and it is also having some, you can say, funny or weird why they gave name. because one of the member, Michael Vidanius, his name, his daughter name is Mai. Okay, and therefore he dedicated to it, and therefore whatever DBMS he made, he gave name to it as MySQL. So please remember, MySQL is a database management system, like Oracle, like SQL Server, like Postgres. Correct? All these different database management systems we have. Same way, MySQL is also a name of a relational database. So you can say MySQL is open source. It's purely developed in C, C++. So if you are a competent C, C++ coder, you can check their whole source code. They are giving the whole source code also, guys. If you go to their website, you can download their zip version and you can see how they have implemented. But to understand that, you should be very competent C, C++ coder. So it's an open source. Open source means they're giving the original source code itself, and it is freeware. Freeware means you don't have to purchase any license or anything. Like for Oracle and SQL Server, like Microsoft SQL Server or Oracle, if you want to use, then we have to purchase the license. And that is the reason many people use the pirated version of Oracle and all. But obviously, industries cannot do all that. They have to take that license. So MySQL, therefore, you should prefer. Now, there are many companies like Deloitte and all, they are going to Postgres, and Postgres is an open source version. Get it? So MySQL is a relational database management system. It is an open source database management system. It's a freeware. You don't have to purchase any license. Go to their website, download, install, and start using it. Get it? And it was developed by Michael Vidanius. And some other team members were there, but the main person was Michael Vidanius in 1995, I guess. And then Oracle has taken over it now. Now it is being taken over by Oracle. Therefore, if you go to MySQL's official website, there will be Oracle marketing also. Get it? I guess in 2010, Oracle has taken over this MySQL project. Okay. And I told you it is a relational database management system. Okay. So therefore, to talk with MySQL, you need to know SQL. Means MySQL will only understand SQL instructions. Okay. So MySQL is an open source. Open source, I hope you got it. They are giving the original source code itself. Microsoft people generally don't give. Microsoft people don't develop such products. They are all closed source product and they are all not freeware. They are all licensed version. So open source freeware, relational database. Okay. And using this, MySQL is capable of managing your data, doing interaction with that with the help of SQL queries. Okay. Developed in 1995, around the same year, Java also came in market by Michael Vidanius, and later it is acquired. It is taken over by Oracle. Oracle has taken over Sun Microsystem also in 2010. Okay. Then the short history about SQL, I'll tell you in short how this SQL concept came into existence. So actually, it is originally it is IBM's project. IBM developed their own relational database management, which is still used, DB2, if you have heard about DB2. Okay. So it is an IBM product. So initially they developed the first relational database management system. Get it? And they wanted one language which user can use to interact with that RDBMS. Means what they wanted, the concept what they wanted, that user will interact with that DBMS as if it is talking with a human, more of like English, but little bit structured. English you can like our Marathi, like if you have Marathi background, Marathi as you manipulate, the meaning can be different. With the same statement, you can interpret in different way. Same way in English also. So SQL is like English, but it is more structured, more towards mathematical model. Okay. But it is as if like you're talking with some other human. That's what they wanted. They wanted that people will interact with our RDBMS, but as if they are talking to some human by typing English statements. Get it? And they came with this concept called SQL. So SQL is a language where the statements what you build or the instructions what you build, they are very much like English instructions. Get it? But they cannot be exact like English. They are more of structured based, or you can say they are more rule based, based on mathematical model. Okay? Initially, it was called as a structured query English language, means SQL. Initially, they gave name as SQL, but there was a trademark issue. Someone had put a trademark on that word SQL. Therefore, they had to rename it and they came with SQL. Get it? And later, there was some standardization also done for SQL because many other companies also started coming with their own DBMS. Means IBM was not the only one who came with their RDBMS. Then many companies in the market started developing their own RDBMS. Understanding what I'm trying to tell. Many other companies entered in the market and they also made their own RDBMS. So now what was happening, their RDBMS was following some instruction, but some instructions were not compatible to our IBM, or some instructions were not compatible to some other company. So there was a need of standardization. Like in web development also, see, like every browser should produce the same page. So for HTML there was a standardization needed, that W3C committee formed, that is called as World Wide Web Consortium, and they created a standard rules of HTML. And then in the market, as many browser making companies are there, they should follow that W3C rules. Same way here also, one ANSI committee was formed, and then they created some standardization of SQL, and then all the companies in the market who are making RDMS, they started following that standardization. But still, little bit changes are there, but you can say 95 to 98% concepts are same in nearly every RDBMS. Okay? Then ANSI committee, then ANSI ISO joined, and then they created some standard rules. Rules in the sense, you got it, like what should be the character set, what all keywords should be there. Then the grammar, they decided grammar of insert query, grammar of delete query, all that things, standardization was done. And then different companies who are developing RDBMS, they have to follow that standardization. Get it? And please remember, SQL comes under non-procedural language. It is not a procedural. Remember, all the programming language, or you can say computer languages, they come under two categories. Okay, one is procedural and another is a non-procedural. Or you can say my paper, I have presented my paper was on that only, evolution of languages, and we have done the study from 1950 onwards, how the languages came and how the evolution, their learning curves, then how some languages have gone in the history, some is still there more than 60 years, getting like C or C++, you can say. So procedural and non-procedural. They are also called as imperative, okay, or declarative. Okay, now you'll say, what is the specialty? Remember, in case of imperative, what to do and how to do, both programmer responsibility. Means what means your problem statement, but the solution of that problem, the algorithm also you have to write. Therefore, imperative languages are algorithmic languages. Like you take C, C++, Python, JavaScript, they all come under imperative. Java, procedural, or you can call it as imperative, meaning what to do and how to do, both whose responsibility? Programmer. Non-procedural languages, here you just have to bother about what. You're not worried about how. How will be taken care by another system. Correct? So you can say like very old languages like Lisp, Prolog. I don't know whether you have heard or no. Haskell, they are extensively used in games and all. Means in some AI models, chess game and all. There still that Haskell and all is used. Natural language processing, Prolog and all is used. So those go under non-procedural. SQL also come under that category. HTML also come under non-procedural. HTML is also a language, guys. Many people they make a fun of it, but HTML is also a language. It is used for designing the structure of your page. Get it? But HTML, you just tell what. You are not bothered about how. Correct? So it is not an algorithmic way, you can say. So SQL also come under non-procedural. Using SQL, you'll just tell what to do. Like insert into employee, you'll give the values. How to insert in that employee, it is the job of DBMS. DBMS will take care. Understanding? Select star from employee. Means you're telling that please give me all row, all column from employee table. Now, how to retrieve that records from the employee table? That is the job of DBMS. DBMS will bring and give you all the records. How is not your job? How is DBMS job? In case of HTML also, it is the job of browser. Browser will see how to present that page. You're just giving the structure of your page using HTML tags. Correct? So, in short, imperative, declarative. Declarative means what to do, not bothered about how. SQL come under that category. Now, languages like JavaScript, Java, they are also trying to introduce these concepts. Correct? Using, I'll not go into much detail because maybe some are not very core programmers. Okay. So what to do and how to do is a imperative where you're only bothered about what, how will be taken, how is the job of some other system. Correct? So that is non-procedural. So SQL come under that category. Okay? So quick history about it. So SQL originated in 1970s from IBM's research project on relational data because they had developed their own relational database management. And they wanted that now to make this relational database management famous, we should provide a language to the user by which user can communicate with our RDBMS. Correct? So with their RDBMS, how people will interact. So they wanted some system as if user is talking to that DBMS, as if it is talking to a human by giving an instruction in English. Okay. So it started as SQL. It's called a structured English query language. Later, renamed to SQL due to trademark issue. Correct. And I said like many other standardization was done. Many other companies started coming into market. They also created their own relational database. Then they will also provide their SQL. So there has to be a standardization with that SQL that the same command should work everywhere. Let it be X company, Y company, Z company. So creating a table. So the command should be nearly everywhere same. To insert a record, the command should be nearly same. You can study also, like once you're done with MySQL, you can dive into Postgres. You'll see nearly 95, 98% everything is same. Correct? So it will be very easy to dive in Postgres once your MySQL is done. Okay? So I hope it is clear to you, the short. And then I said some standardization committees came and then they created some standard rules. And then many companies who are making their relational database, they started following that standardization rules. Okay. And already I told you, structured query language, it is a non-procedural language. Okay. It's a declarative language. And using this language, we are going to instruct to the DBMS. How user will instruct to the DBMS? Only by using, this is your database management system. It is saying that I can obey all the command. I know what command does, I know what command is for what purpose. So it can take the command, compile the command, execute it, do appropriate changes, but you have to instruct. Correct? So how you're going to instruct? By using SQL commands. Understanding? Okay? So the basic idea is clear. So I hope you can give me quick confirmation about it. So SQL is a non-procedural language. And using SQL commands, we are going to interact with the DBMS. Understanding? Clear? So why we should call non-procedural? If you have understood, anyone can just quickly, in short, you can tell me. Let's see.
We are not
Just
writing any functions, or we are not uh, like we are just trying to interact with the existing data. So to fetch
means
our data, we are using SQL, right?
means you want to say just we are telling what to do,
Do
right? We are not telling
we
how to
have
do.
to how to do? Yes,
Correct? So how to is not our job. How will be the job of DBMS? We are just telling what to do. Means we are
they
telling just please insert these values in my table. Now, how to insert it, finding the table, adding the record in it, that is the job of DBMS. So therefore, instead of elaborating too much, you can just say that why it is called non-procedural, because in this we are only bothered about what. We are not bothered about how. How will be taken care by DBMS. But if you are a core programmer, like you have done programming in C or C++, there you might have seen whatever problem is there, its solution also you only write. Like if the problem is finding GCD of two numbers, then you only write, you accept first number, you accept second number, then Euclid method is there in a loop. You keep taking the mod and then swapping. That whole procedure, who is writing? We only. So what and how? Both our job, then it is procedural. Only what, not bothered about how, it is not procedural. Correct? So I hope it is clear. Then SQL helps us to do all the CRUD operations on the database, like creating your tables, inserting records, reading that record, updating record, deleting record, all that facility who gives SQL. Okay. So in short, how SQL will help us? Obviously, it will help us to create our database. It will help us to do manipulation on it. Correct? It will help us to retrieve the values. Then it provides you with the security facility, authentication, authorization, all facilities SQL gives. Okay, so SQL allows user to perform a variety of tasks related to database like retrieving. Now, retrieving means not reading all. You can retrieve in a filtered way also. Like in your database, there is an employee table. So only reading all records and giving you. Not only that, it also does the work of filtering as well. Like you want only the employees from sales department, or you want employees whose salary is more than 50,000, or you want all the employees who stay in Pune city. So this way filtering also you can do. You can even join one or more table and then retrieve the record. All we are going to learn, guys. And based on that, only the scenario questions are there, which are asked in interviews. So retrieving the data, you can do it with the help of SQL. Then manipulation, like adding new records, then deleting the existing records, making changes. Correct? Like as new employees joining, we have to add that record. If the employee's designation is changing, employee city is changing, the salary is increased, you have to do modification.
oh,
Correct? If the employee is leaving the company, you have to delete the record. Okay. So all that facility. Then you can define the design of your tables. Like what will be the name of my table? What columns will be there in it? What will be the data types of each column? Correct? I want to make a table. So what will be the name of my table? What columns? Names of each column, their data types, their constraints, all that things also you can tell with the help of SQL. Get it? And you want to do fast retrieval, then you can add indexes on it. A separate topic will be coming. At the very end, it will come, but there will be a separate topic called index. And on index also, interview questions are asked, like how index help to do the retrieval faster. Get it? So that is also a very favorite question. And then controlling your data. Like, for example, you are the owner of your database management, your database, not database management. It is a software which is going to take care of it. You are the owner of your database. Database means collection of tables. And maybe the tables are connected with each other, not physical. They don't have any physical connection. They have some columns in common. So you have multiple tables. This is your database. And you want to give the permission to access this table to another user. Correct. Generally, these commands we don't learn because our intention is to learn SQL from data engineering point, data analytics point of view. Okay. Generally, these commands are for specialized users like DBA, database administrators and all. For them, it is useful. But if you are the owner and you want to give privileges of accessing your data to someone else, correct? So that is called as authorization. There is a difference between authentication and authorization. Authentication means confirming whether you are the legal user to access this or not. That is authentication. And authentication is done by username and password. So first it will confirm, it will accept username, it will accept password. If it is validated, then only you are authenticated to access it. Done. But once you're authenticated, you want to give the privileges to another user to access your database. Means the other user can see your tables, or it can add records in it, or it can delete records from it. So what permissions you are giving? That is called authorization. Authentication, I told you, username, password. Authorization means you are giving the privileges to some other user. You can take that privileges back. Get it? So that is granting and revoking. All these facilities who give SQL provide. Get it? Now our next step is installation process. Okay. But before that, just two things I have to tell you. And then in the next session, our next session will start only with the installation. Okay. And once the installation is done, we will start our practical things. Okay. I'll be telling the commands, then we will practice that commands. Okay.
Hello, Ajit.
Huh. Yes.
One doubt. So I do not have my personal computer. So in my office laptop, I have PL SQL installed. So with the same queries, I can practice, no?
Uh, some part may be different, some part like data types and all, but major
Okay,
commands are same. Major means
okay.
I can say like
Is there
97.
any site online browsing site to practice in
Direct
online?
online. Yes, we have.
Mm.
Yes, I'll tell you,
Oh,
don't worry.
okay,
Without installation and all. You don't want to
okay.
install on the local machine and just directly online you want to practice. Yes, you can do it. Okay. I'll
I'm
tell you.
actually working in Oracle. So I have joined as a business analyst here. So what is
Okay.
happening now? So they're asking me to, use database, their existing database to, solve any issues in the production like that. So
Okay.
for that, I have joined this course because I'm not familiar with this SQL.
Okay.
So yeah.
So this course will go with the very basic. Yesterday also
Yes, that
someone
is
else
what
had asked. Yesterday
I know
someone
that.
asked like he wants to learn only the stored procedures and all. But here you have to go with all the basics
Yes,
till
yes,
that. Okay. I'll show you the online website where you can
yes,
practice and
yes.
nearly like you can say 97, 98% is same. Like creating
exactly.
tables, inserting record, near about the queries the same. Little bit
My,
change in the data types and all may be there. Correct?
See, my objective is like see, I don't have to write any procedure or something like that here. So my like what is their expectation here is like I should be able to fetch the data or write a few complex queries to
Yes,
retrieve the data, and
right.
if there
So
is any issues like
your requirement is still joins, window functions, and all those things.
yes. So
That
just
much
to
is sufficient.
understand that in a
Hmm.
package there will be some code, no?
Hmm.
So like to understand the flow, like they're expecting these kind of things from me. So I
Right.
thought, okay, this will help me.
It will sure help you. Or whenever you're planning to switch in some another profile, some
Hmm.
better option, that time also it will sure help you. Correct?
Okay, thank you.
Okay. Quickly, I'll just tell you. Now, whenever you are installing MySQL, there are two parts in it. One is your MySQL server, okay? And a MySQL server is, you can say it's a program which is continuously running in the background. And MySQL server is your actual DBMS, you can say. It is responsible to take the client queries, check whether the query is correct or no, compile that query, execute that query, make changes in the storage, generate response to the client. So MySQL Server is your main database management. It is responsible to run the commands and handle your database. And so we have to install this. MySQL Server is mandatory. You have to install. You consider Postgres also. Postgres will also have their Postgres server and they have their client tool. Get it? And from where the client will be able to type the command. This is just a database management system. And this is a program which is continuously listening for the client query, compiling the query, making changes in the database, and generating a response. But we need to provide some environment to the client from where the client can type the query, submit the query, see the result of the query, do administration, like client can see all the databases, what he has created. Okay, how many tables are there in each database? Client should be able to see the errors. So for that one, client environment is provided. That is called as MySQL Workbench. Getting MySQL Workbench. This is same for all database management, guys. Like if you go to Postgres, so Postgres will have its own server, okay, and it will have its client software called PSQL. So PSQL is not the database management. Before that, you start with your Postgres service. Get it? Service PostgreSQL start. If you do it in Unix environment and all, so they on the terminal you type like that service PostgreSQL start. Then the Postgres server is started. But then the client software should be there, no? From where the client will be able to type the query and see. So for that we have PSQL and give the database name. Then the environment come where client can type query and see the result of the query. Exact same here also. Same for other database also. Oracle is also having its Oracle server. You can check in that services oracle.exe and they give one SQL plus tool where you can type the queries. So that is the client software. So please remember MySQL Workbench is the client software. It's a client user interface and through which first MySQL Workbench has to establish connection with this by authenticating the password, username, and all. So connection is established. Now, through MySQL Workbench, that is UI, you'll be typing the queries and submitting to DBMS. DBMS will run the query, produce the result, give the response, and that response is again seen in this workbench. Get it? So MySQL Workbench is not the DBMS. It is just a user interface provided to the client through which client can interact with the DBMS, connect with the DBMS, submit the queries to the DBMS, collect the result, show the result to the end user. That we do it through Workbench. And the actual DBMS is your MySQL server. So tomorrow I'll show you how to install both the things. the server also and the workbench, and then we'll start working in it. Okay?